Okay, so induction and divisibility follows the same process as we have done before. So we're going to start off with, let's just make sure we are clear just in case you haven't done it before. So n in n, that's just all natural numbers. And so like we've done on many occasions before, we're going to start with, let's prove P1. All right, so we end up with 7 to the 1 plus 5. Okay, so that gives us 12, and that is definitely divisible by 6. Okay, so therefore P1 is true. Now, just like before, what we then have to do is we want to assume that PK is true. So for us, that means that we have to assume that 7 to the n plus 5 is divisible by 6. So we'll say that this is going to equal 6 times a, where a is some type of natural number. Okay, so it's an integer. All right, and what we want to do, like we've done before, is we are hopefully going to use this PK to help us prove that PK plus 1 is going to be true. So this time we don't sort of write PK and then the K plus first term, right? We are just going to substitute K plus 1 into our original statement. So we've got 7 to the K plus 1 plus 5, and what we want to do is try and prove that this will be 6 times something. And once again, we have to use PK. One of the tricks here, every single time, is we are going to separate this little bit here. We're going to do that using our index rules. I hope you will agree with me that that is going to be 7 times 7 to the k. Okay, so remember, timesing by the same base, you add the power, so 7 to the 1 times 7 to the k is definitely 7 to the k plus 1. Maybe I'll pop that as a times instead of just that dot. It's old school. All right, and we've still got our plus 5. So now we can confidently substitute, oops, I forgot to put that as a k. We can now substitute our PK because we say here that 7 to the k equals 6a take 5. Okay, so this becomes 7 times 6a take 5, and we've still got our plus 5. And we know that we're on the right track because we are saying using PK. If you don't use PK to help you prove PK plus 1, we're in strife. Okay, now 7 times 6a. I can say that's 42, but I much prefer saying that 6 times 7a. Why? Because I'm going to try and pull out a common factor of 6. 7 5s are 35 plus 5. So we've got 6 times 7a minus 30. Huzzah! I can pull out my 6, my common factor of 6. Okay, and we've got where, right, since a is an integer, and we're timesing that by 7, we're taking that, then that is also an integer. So therefore, PK plus 1 is divisible by 6. And the best bit is that your proof, right, your statement is the same for what you have done on every other induction proof with the sums. Okay, because we're restating what we did. We started by saying since P1 is true, and then we proved that PK plus 1 is true using Pn, or in other words, when PK is true, then our original statement, Pn, is true for all n in the natural numbers by mathematical induction. There she blows. One little thing, I guess we should actually make sure that we do know that that is our Pn statement. Sometimes people get a little bit uppity if you haven't got that there. All right, so we'll try a slightly harder one in the next example. Look out for that vid.